Okay, two last Newton's second law questions that I'm going to do in a video. This one's about a grocery bag trying to be lifted up. Hopefully it doesn't break. So let's see what happens here. Start with a free body diagram. So we could call that maybe FP for pull. So pull on bag. And it also has some force of gravity, earth on bag. So Fg equals 20 kilograms plus force of gravity, which would be 9.8 meters per second squared. Or 96. I could have done that in my head, sorry. And we're told that the maximum that bag can withstand is 250 newtons. So FP 250 newtons. That means F net is equal to FP minus Fg, which is 250 newtons, minus 196 newtons, which is 54 newtons. I could have done that in my head too. E. So that's the maximum net force it can take. So let's see what acceleration that is. 20 kilograms. I could do that in my head. That's 54 divided by 2 would be 27. So that's 2.7 meters per second squared. Ooh, no, the bag will not hold. If it's accelerated upwards at 5 meters per second squared, that means there's a much greater net force than 54 newtons, which means that the pulling force up would have to be greater than 250 newtons. And El Snapple Reno. Okay, last question that I'll try here. That was 14. What's one to try? I was going to try elevator question. Number 15. So you have a person on a scale. So let's do the free body diagram for the person on the scale. So normal force, scale on person, and Fg, earth on person. Remember, scales measure the normal force. So when the elevator is at rest, so at rest, Fn equals Fg equals 864 newtons. So that means mass is equal to Fg divided by g. So the mass of this person is 88.16. The reason why we say when the scale's at rest, those two forces are balanced, and that's why Fn equals Fg. Okay. Anyways, what the first question is, when it moves up the scale reads at 935. So what's the acceleration? So F net. Okay, we don't actually need to know that yet. Actually, do we? Yeah. F net equals Fn minus Fg. So that equals 935 newtons minus 864 newtons. And because I'm lazy, so that's a net force of 71 newtons. So the acceleration is F net divided by mass, 71 newtons, divided by 88.16 kilograms. .805 meters per second squared. There's the answer to A. Then it starts to slow down, I guess, if the scale is reading 782, which is less than the force of gravity on the person, that mean that force of gravity has to be bigger. So it's a situation where F net, so it's accelerating downwards now. F net equals Fg minus Fn. So that's equal to 864 newtons minus 782 newtons. What is that? 64 plus 18. 70. 82 is it? Oh, I better check that. Okay. Acceleration's F net divided by mass, which is equal to 82 newtons divided by 88.16 kilograms. So 0.93 meters per second squared down. This one was up. That's down. Okay, what about question C? Explain the change in scale you expect on the ride back down. So as you go back down, at first, so when you first start to go back down, your acceleration will be, your normal force or scale will be less than 864. It's accelerating down, which means that Fg is bigger than Fn, like this. And then once it gets to the bottom of the elevator, Fn should go bigger than 864 newtons, because at that point it'll be accelerating upwards. So like that. So Fn must be bigger than Fg. Okay, there you go. Good luck with the rest of this review sheet.